Today we're here to talk about domain and range. When we're talking about domain, we're talking about all valid x values. When we read the graph for domain, we are going to go from the left to the right, just like we were reading or writing. So we're going to go from the left to the right. An arrow going left means that x is going toward the negative infinity, and if that arrow is approaching the second or third quadrants, again, that means that x is approaching a negative infinity. If x is approaching the right, x is approaching a positive infinity. X just keeps going and getting more and more positive. This occurs when the graph is approaching the first or the fourth quadrants for domain. A continuous graph like this one, where I can draw the line from this side to this side without picking up my pencil, uses the number set all real numbers, denoted by a capital R. When we write that in math, we do that with a capital R with two legs. I mentioned the word number set, and we are going to use discrete versus continuous graphs to understand number sets and how they play a role in domain and range. I can tell that my left graph is discrete because my dots are not connected. On the other hand, I can tell that my right graph is continuous because if I draw the graph, I don't have to pick up my pencil. It is a solid line, so if it's a solid line or curve with no breaks, it is continuous. This is the full number set made up of complex numbers and imaginary numbers. We are going to defer our conversation about complex and imaginary numbers until we study quadratics in the third 6 weeks. Right now, when we're talking about discrete and continuous functions, we are talking about the real number set in this dark blue box. This is our real number line. Real numbers include natural numbers, whole numbers, integers, rational numbers, and irrational numbers. A brief description of each of these numbers. Natural numbers are our counting numbers, 1, 2, 3, 4, and so on. Whole numbers include the 0. Now, if we want to get into negative numbers, we need to go up to the integers. When I write in set notation, I will specify the set of numbers I want. So, for instance, if everything is 0 and positive, I will use n for whole numbers. I will use a z if negatives are included, and I will use an r if both irrational and rational numbers. The only difference between a rational number and irrational number, if you look, these are all decimals, and so are these, basically. But what is different about this decimal and the square root of 2, if I were to put that in decimal format, is rational numbers form a pattern after the decimal sign, while irrational numbers form no discernible pattern after the decimal place. Again, if you put the square root of 2 into your calculator, you will see a bunch of numbers after the decimal sign, but they form no real pattern. We will use natural numbers, whole numbers, and integers mainly for discrete functions, and you will use real numbers mainly for continuous functions. The number set I'd use for this discrete graph is whole numbers, and that is because it includes 0 all the way up to 4 on my x-axis. So it would go from 0, 1, 2, 3, and 4, not 5 actually. Therefore, for this discrete graph, I would use the whole number set denoted by the symbol n because it includes 0 and all positive numbers. This function starts at 0. I do not pick my pencil up when I go. It has an arrow, meaning that it goes to a positive infinity. All numbers are positive, but the domain contains everything between here, and so does the range, so it includes irrational numbers and rational numbers. Therefore, this continuous function would use the number set all real numbers, denoted by a capital R with 2 legs. Writing the domain, I can use set or interval notation. So we're going to see we have a continuous graph. The number set that we're going to use is all real numbers, denoted by the capital R. And we are going to look really quickly to see how we would write set and interval notation for the domain. Before I begin writing in set notation, we have to do a quick review of our inequality signs because inequality signs are actually used in set notation. This is our less than sign. It's less than because it's littler on this side than it is on this side. I read left to right, so this is littler, so I'm going to say it is less than. This, on the other hand, is greater than because it is bigger on this side. It's wide, it's open, it's greater than this side. This is my less than or equal to and my greater than or equal to. I explained to students that this is the less than or equal to sign and greater than or equal to sign by showing them that an equal sign looks like this. So to make it less than, they just took the top of the equal sign and did this to create the symbol. And the greater than sign, again, they started with the equal sign and they said, well, it can be any number that's equal to this or greater than, so they just added the greater than sign. The reason we need to know this in set notation is that sometimes our lines don't contain arrows, but they're line segments and they might contain an open dot at one of the points. And if it's an open dot, we're going to need to use the less than or greater than. And if it's a closed dot on our graph, meaning that it doesn't go to infinity but it stops somewhere, we are going to use the less than or equal to or the greater than or equal to. Okay, one final thing I want to go through. I've talked about set notation, but we're also going to have to worry about interval notation. Interval notation. And if my graph has an open dot, I'm going to use parentheses. And if my graph has a closed dot, I'm going to use brackets. And we'll practice these more later to help you know when to use what. Set notation reads like a sentence but uses math notation so you don't have to write a long sentence to describe the domain and range. For instance, if we look at the graph we started with, you could describe the domain in a sentence as follows. The domain, all valid x values, includes the set of all real numbers. How do I know that it's all real numbers? Well, if I look on the left side, I can see that this is pointing, arrow's pointing left, so I know it's going to negative infinity. So it's all valid x values that are all the negative values. And then if I look on the right side, I can see that that arrow is also going to the right, so it's going to a positive infinity, so all positive values will work. Now when I'm writing set notation, I am going to start with a bracket, and it looks like this. It's a French bracket. I call them squiggly wigglies in my class, but the official term is a French bracket. And I would say x is an element, and this is like a C with a line in the middle. It's kind of a funny looking E. And then I would say all real numbers, again, that's the capital R with the two legs, close bracket. And this is how my sentence read. The domain is a set of all valid x values that includes the set, and this is what includes the set of all real numbers. Interval notation does not specify a number because it's used only to describe a real situation, in other words, in this case, a continuous situation. Interval notation does not specify a number set because it's used only to describe a real situation, in other words, a continuous situation. The starting and ending numbers are enclosed in square brackets or parentheses separated by a comma. Square brackets are used to indicate the number is included, and this, instead of having an arrow on the end of our graph, we would have what we talked about in the slide before, a closed point, like that. Parentheses indicate a number is excluded in the domain and range. Parentheses are also used around infinity because you can never touch infinity no matter how far you go. Again, we've talked about this graph, and we've talked about the domain of this graph going from a negative infinity to a positive infinity. Okay, so using all of this information, if I were to write interval notation, I would use a parenthesis because, again, you can never touch infinity, and I would go from a negative infinity, comma, to a positive infinity, and again, I would use a parenthesis. And that's my interval notation, and it is very simple. Most of my students prefer using interval notation to set, but we will ask you to demonstrate your knowledge of both set and interval. And again, interval is really only used on continuous functions. We've spent the majority of this presentation talking about the domain, and now we're going to talk about the range. The reason we could spend so much time on domain is that everything that we talked about with domain applies to range, except the range includes all y values, all valid y values. When we read or write the range, we're going to look from the bottom first to the top. So we're going bottom to top. In other words, we're going from our lowest y value to our highest y value when we are writing the range. This is practice 1 for domain and range. We're going to start with domain. I'm going to go to my graph, and I don't see arrows, so I know I have no infinities here. So what I'm going to do is I'm going to go to the left side of my graph and draw a line down to my x-axis. And I'm going to see that it crosses the x-axis at a -3. I'm going to do the same thing on the right side. I'm going to see that my x crosses then at a 3. So I know that my x is somewhere between a -3 and a 3. So if I go back and I look at doing set notation, I'm going to do the French bracket. So we're going to draw our French bracket. I'm going to say x is an element of, hopefully you can tell this is a continuous graph, because if I go from here to here, I never pick up my pencil. So if it's continuous, we learned before that I need to say all real numbers. And now this is a new thing that I need to do. Our last example showed us with arrows on either end, and this was it for our domain, for our set. But now I have this caveat here where it's x isn't anything, x is between a -3 and a 3. So I have to put some extra stuff in my set notation to say it's not just all real numbers, it's the real numbers between a -3 and a 3. So I'm going to draw that. Finish off with my French bracket, and I know my x is somewhere in between. Now this is where our inequality sign comes in, because if I look at this side, I see an open bracket, so I know that -3 is not included in my set. That line is going, it's getting closer and closer and closer to a -3, but it never touches it. So I'm going to say that -3 is less than x. And then I also know that my x is before the big 3, the +3, so I'm going to say that my x is less than, and instead of just less than, it's going to be less than or equal to. Why is that? Answer for yourself. It's because it has a closed dot on this end. Okay, now let's look at interval notation. If I look at interval notation, I know that I need parentheses and brackets. It's easier. If I look then, again, we do domain left and right. If I look at the left, it has an open parenthesis, it has an open period or dot, and so I know that I need to use a parenthesis. And I'm going to go from a -3, comma, all the way to a 3, and on this end I see that it is a closed dot, so I'm going to use a square bracket. Now we're going to look at the range. For the range, I start bottom to top. So I'm going to go to the lowest point on my graph and bring it to the y-axis. And I see that it crosses the y-axis at a 2. And then I'm going to go to the topmost point, and I see that it crosses my bracket at a 4. So again, I'm going to do set notation now. I'm going to say, give my French bracket again. Instead of x, domain is x, but range is y. So I'm going to say y this time is an element of, again, it's a continuous function, so it's going to be all real numbers. And this line, I talked about it before, but I didn't say what it meant. If I'm reading this as a sentence, that line means such that. It's putting that caveat on that we talked about earlier. So y is an element of all real numbers such that, and again, I'm going to go from a 2, my x is in the middle, my x, not an x, Miss D. That should be a y, so we are going to go to the y. How about that? Y is in the middle, from a 2 to a 4. Now, I am going to then try to figure this out. At the lower end, I see that it's an open dot, so again, I'm going to say 2 is less than y, and then y is less than or equal to 4, because 4 has the, again, that's the end with the closed dot, and I'm going to close that with my beautiful wiggly squiggly bracket. All right, now let's look at interval notation for the y. Again, interval, I'm going to start at a 2. It's going to have a parenthesis because it's an open dot, comma, 4. Again, it's going to be a closed bracket because it has a closed dot on that point. Now we have done practice 1 and showed you set and interval notation for both domain and range. I am going to use set notation for this example. This is an example of a curve instead of a line. It is a quadratic function, actually. So if we look at our domain, I'm going to start with our French bracket, and I'm going to say x is an element of. Now, if you can see, this is a continuous curve. I do not pick up my pencil when I draw it, so I'm going to say of all real numbers, and then that, do I need a such that on this one? We're going to look at that and see if we do, or if this is good enough. I see an arrow in my second quadrant on domain. That means that my x is going to a negative infinity. In quadrant 1, I see that I have an arrow going right. That means that my x is going to a positive infinity. Therefore, the domain is just x is the element of all real numbers. I don't need a such that on this domain. But what about the range? So on the range, again, we read bottom to top. But on the bottom, I see this. I see a curve that is touching at a y value of a 2. So when I see that, I say, my y starts at a 2, but then on both sides it gets bigger and goes to a infinity. Okay, so my range has a little bit of a restriction. I see that y is an element of all real numbers. It's all real numbers because it's a continuous function. But I have to do this caveat, this such that, because y is not negative. It never goes down here. It is only positive. So I have to say y is greater than or equal to a 2. Now, why did I say or equal to? It is because I have a solid curve that goes through this 2, so I'm going to say equal to on here because it does touch the 2, and I'm going to close it with my French bracket. And that would be my domain and range and set notation. Domain, x is an element of all real numbers. It has arrows on both the second and the first quadrants, both the left side and the right side. My range is y is an element of all real numbers such that y is greater than or equal to 2. Practice 3 looks a little different. It might look a little bit more complex because it's got this little thing right here, but we're going to do domain, and I'm going to show you that you're going to use the same principles as before. Domain, I read left to right, so I'm going to go to the left side and I'm going to pull this function down, and I'm going to see that it crosses my x-axis at a 1, 2, 3, 4, 5, a negative 5. Okay, I go left, I go all the way to the right. I'm going to go to this where it's an open dot, and I see that my x crosses at a 1, 2, 3, 4, 5, a positive 5. Okay, I don't have arrows at all on this function, so I'm going to have a such that. So I'm going to draw my French bracket. I'm going to say x is an element of all real numbers such that my first x starts at a negative 5. It is less than or equal to because the dot is closed. My x goes in the middle. And I'm going to say a less than 5 because it's an open dot at the end, close parentheses. All right, now I'm using set notation for this one. My range then is going to be y is an element. I'm going to switch to green here as an element of all real numbers. So we're going to change my range to the green. Again, I go bottom to top with my range. So I look at the bottom of the graph, and the bottom of the graph crosses the x-axis. This is where y would equal 0. So I have a y equals 0 here. And then I look where it crosses the top of the y-axis, which is up here. And this is going to be a 1, 2, 3, 4, 5, 6. And that's a 6. So I know my y goes from a 0 all the way up to a really poorly written 6, but that is a 6 up there. Alright, so I'm going to say y is an element of all real numbers such that y starts the bottom, I write the bottom first, 0, and because this is a solid line that goes through that point, a solid curve, it's a curve, Miss D, not a line, I'm going to say 0 is less than or equal to a y. And then again, it's going to be less than a 6 because it is an open dot. And there is my domain and range for practice 3. Also, please ignore at the top where it says the union. That's actually going to be on our next practice example. This is our last practice, and it's called a union. I tried to introduce this in practice 3, but that was not a union, but this is. To make this easier, we're going to look at each of these pieces separately. This is going to be piece 1, and this is going to be piece 2. Now, this is a discontinuous graph, so because I would have to pick up my pencil to draw it, but it is not discrete. That is because this piece of the graph is continuous, and this piece of the graph is continuous. To combine these together, we are going to use what we call the union symbol. It looks like this. It's just a U. And what's that going to mean is that this piece of the graph that we talked about is 1 and 2. We know that the domain and range is going to contain values in piece 1 and in piece 2. And so what we want to do is use the union symbol to combine both pieces. In this case, I'm going to use interval notation, and that is because even though it's a discontinuous graph, each piece is continuous. All right, so let's look at the domain first. I'm going to do the domain in this time in blue. Again, I read left to right. If I look at the leftmost side, I see an arrow. An arrow in the second or third quadrant, I hope you remember that on the domain, means that x is going to a negative infinity. So that is where we're going to start with our domain. I'm doing interval notation. I know that it has to be a parenthesis because it never touches an infinity, so negative infinity, comma. And I can't go all the way to the end over here. I have to actually go to this end piece first. So I'm going to go here, and I'm going to say that this end stops at a -2 when it crosses the x-axis. So I'm going to go from a negative infinity to a -2. And at that -2, I see that it's a closed dot. So I know that I need to do a bracket here, a square bracket. Now, this is where our function jumps from here to here. It jumps all the way up to here. So I am going to do a union from that point. Now again, I have to, from this graph to then, I again have to go left to right. So the leftmost point on this one crosses the x-axis at a 2, and I'm going to use an open parenthesis. Can you tell me why? I hope you can, because it's an open dot. I'm going to do comma, and then I see on the leftmost side here that it has an arrow, so I know that my x on this side, because of that arrow, is going to an infinity. So I'm going to write infinity, close dot. There's my domain. Now, we're going to do the same thing with our range, but instead of going left to right, I'm going to go bottom to top. So if I look at the bottom of this, this is actually, the bottom is this arrow, because this arrow is going to keep on going down and get lower and lower. I know then on my y-axis that that means it goes to a negative infinity. So just like on my x, my y is going to start at this negative infinity, wherever that is. And then it's going to go up, and I have to go to the top of number 1 this time. Remember, we're on this first graph, and I see that the top crosses here at the x-axis at a 0. So my y, the topmost part of my y on this side, is a 0. Again, it is touching the x-axis here at that 0, so I am going to do a bracket here because it is actually including that 0, union. I'm going to go then to this side. I'm going to go bottom to top. My bottom on piece 2 starts at a y of 0. So here's my y of 0. Again, it is a bracket because that 0 is included in the function. It is a solid curve that is touching that 0. And it's going to go all the way up. Oop, I see another arrow. I know that that means that my y is going to an infinity. So I'm going to go 0 to infinity. And I have to use a parenthesis to do that. And that would be my domain and range for this union. This video gave you an overview of domain and range. The last 4 examples were very good examples of continuous graphs. In class, we will practice a little bit more with the discrete graphs so that it will help you identify whole numbers and integers. Thank you, and I look forward to seeing you next class.